When my first child was very small, I thought, I got this. She's so quiet and cheerful and sleeping through the night and so sweet. I'm a great parent, obviously. I'm not going to have to change a thing. And then she got a little older and her sisters came along, and I realized I was on a roller coaster ride that was going to last at least 18 years. And I now realize it's going to last forever. And that's where humanity is right now with artificial intelligence. It was so sweet in the beginning, and now it's growing so fast, and we don't know what kind of trouble it's going to get into, especially around issues related to diversity, but also generally. And we're all going to be held responsible for it, or at least experience the outcomes. So when Juliet Powell and I began working on the AI dilemma about a year ago, I started to think that what we were really doing was a kind of baby and child care book for the parents of this new type of technology. And the parents are all of us. And essentially, the dilemma is that the technology in the wrong hands is immensely dangerous, but in the right hands, it's beneficial to everyone. And it's up to us to figure out how to make the difference. And we're holding both hands. The hands belong to all of us in a way. So the 7 principles that we came up with reflect that dilemma. And let me start by inviting you to imagine that you are a self-driving car. You're an algorithmic system. You're automated. You're thinking on your own. It's not quite thinking, but you have a range of data and you're making value judgments. So for example, if your brakes give out, you might have to decide whether or not to keep driving straight and hit a pregnant woman, or swerve and hit a dog. It's a grim choice, but which one are you going to kill? Or suppose that it's, a small family or a group of elders. Who are you going to hurt? This is the well-known trolley problem. And it means that, there's a terrible decision to make. You have to make it at great speed. And your decision depends on what values you have thought about ahead of time, or your programmers, more to the point, have thought about ahead of time. So who are you going to hit? Are you going to hit women, or are you going to hit men? Are you going to hit athletic people or sedentary people? A group of research scientists at the MIT Media Lab created this experiment. They put up a platform and they asked people to weigh in on these kinds of choices. And they gathered almost 40 million decisions in 10 languages from millions of people in 233 countries. And guess what? Humanity does not agree on who should be spared and who should be killed. There are only 3 choices that most people really agree on. If possible, we'd favor, hitting fewer people and sparing more people. We'd favor saving humans over pets. We'd favor saving children over adults. Those have a large amount of consensus around the world. But otherwise, older adults or younger adults, wealthy or, less wealthy, people disagree on who to save, partly based on their culture and partly based on their temperament. There are cultural differences around the world. And the moral of that story is, how are we going to design instructions and guidance for automated systems that reflect our values when we don't even agree ourselves as humanity on what those values are. AI is like a forcing function. It has illuminated what we do because it's automated it. It's made it operate at a much faster speed. It's made it harder to intervene and to stop it. And therefore, we are now starting to pay attention to what we do because we're seeing it reflected back at us through systems like ChatGPT. I mean, Verona, your exercise showed that the conventional wisdom about how to run a meeting and how to facilitate is right there coming back at us, and you can change it and adapt it. But there are ways in which it might transcend the conventional wisdom, but even those ways reflect all the data that it has gathered about who has done meetings and how those meetings have worked in the past. I kind of played the moral machine like a computer game. I didn't take it that seriously. It's, who do I spare? Who do I kill? It was kind of a little bit abstract. But then at the end of the game, at the end of the experiment, it asked me 3 questions that really threw me. First, did I believe that my decisions on the moral machine will be used to program actual self-driving cars? And I know automakers, I know corporate leaders, and they don't always listen to the outside world. I had no confidence that any decisions, any influence would actually be used in programming self-driving cars. To what extent do I feel I can trust machines in the future? I really want to trust machines. Life would be so much easier if every time I clicked accept on a new program, on a new website, that I could trust that it would use my data responsibly. But I had to admit now that my trust in machines was taking a nosedive, probably like most of the people in this room over the past few years, and certainly like people around the world. And to what extent do I feel that machines will become out of control? That depends on what we mean by control. What we know is that machines that cater to us, machines like generative AI, like ChatGPT, like DALL-E, like these image generators and text generators and conversation generators, they give us the feeling that we are in control. They make us seem like we're getting more done, more productively, with better writing and really cool images. But actually, we are losing control over our ability to get the results we perhaps most want, unless we pay even more attention to automated systems than we do to the rest of life. And so in the rest of the few minutes here, I'm going to talk about what it means to pay more attention. This group, this is a room full of people who are very concerned about diversity and differences and making sure that people are treated with respect no matter where we come from and how we interact and how we come together. And AI's track record for that so far in human history is mixed at best. So it's kind of up to us to make it better. The first principle for thinking about that is be intentional about risk to humans. It is not possible to avoid risk with programs that do unexpected things. But what we can do is take risks intentionally, knowing what the cost may be and thinking through how to minimize the harm in advance. This man is a hero of the Cold War. His name is Stanislav Petrov. He was lieutenant colonel with the Soviet Union Air Defense Forces in 1983. He was at the desk where they looked for incoming missiles from their enemy, the United States. And one morning, he saw 5 incoming missiles. His instructions were to communicate that to his superiors, which could have led to retaliation and to nuclear war between the two countries. Instead, he had a gut feeling that something was wrong, and he communicated upwards that the machine had shown a sign of missiles coming in, but that it was malfunctioning, most likely. And that created a very different response. There were no retaliatory moves, and we are still here to talk about it. When we heard that story, Juliet and I thought nobody's ever going to put an AI program, an AI system in charge of nuclear weapons without a human being intervening. They just couldn't be that short-sighted, that overconfident. And then we started asking around. We asked nuclear physicists, people who had experience with nuclear weapons, and it turns out they were as worried as we might be. So, for example, here's a quote from Marcus Sabols, a professor of physics at Columbia University. There is a continuing push for increased automation in nuclear weapons. In a changing, chaotic, and globally competitive world, AI automated weapons of mass destruction are a terribly scary eventuality. One example of a group that is trying to be intentional about risk, is trying to avoid AI systems being used in ways that cannot be undone, is the European Union with its AI Act. I'm watching it very closely. You may find more and more news coming out about it because it divides all sorts of basically all AI programs into 4 groups: unacceptable, high risk, limited risk, and minimal risk. Minimal risk is it's fine. Limited risk is it's okay if you reveal that you're AI. A chatbot that pretends to be human is unacceptable. But a chatbot that you know it's a chatbot, that's going to be fine. If, assuming that the law stands when it's passed. High risk is you need an auditor to oversee the company. And unacceptable, threats to human safety, livelihood, voice toys that encourage dangerous behavior, some forms of surveillance systems. If you're selling those systems and the law passes, starting around 2025, perhaps, you may not be able to do business in the EU. There's still a lot of debate and discussion about what this will mean and how it will be implemented and how companies will respond. But it is a sign that in many circles, people are taking the question of intentional risk seriously. Another principle has to do with transparency. We call it open the closed box. This is Grandmaster Lee Sedol playing AlphaGo, which is the Google program that won the World Grandmaster tournament in 2016. It did it by using a strategy that was not in the Go literature. And when people said, how did it learn that strategy? Where did it come from? There was no way to find out because chatbots, algorithmic systems, they're based on data. They work with data, but they're not designed to track how they exactly have amalgamated the data that they come from, that they've gathered together. So for instance, I showed this image right at the beginning. Here's very much like you did, Vroni, I put in a prompt. I want an impressionist image of a single human being concerned about artificial intelligence, wondering whether it would be harmful or helpful to people. It's not quite a human being. That thing behind it is a plate, not a hair, or maybe not. It's got pimples and some sort of green metallic looking thing on its chin. And yet it works. It kind of works. But how did the algorithm come up with that particular image? Why did it make those choices? I have no idea, and nobody knows, because you can't ask. That's going to have to change, and it's not going to change by querying the data or the software. It's going to come by querying the companies and what their intentions were in releasing programs. I'm going to move pretty quickly, but I know this slide, our third chapter or our third principle is around confronting and questioning bias. Those percentages are the error rates for identifying people correctly. In other words, the more you move towards the right, the darker the skin color in most cases, the higher the likelihood that that these softwares will misidentify an individual. An eminent researcher named Joy Buolamwini developed this diagram, and it became part of a growing body of interest in reworking the data fed into systems, so that they are more accurate in how they perceive all people, and B, so that they are less likely to do harm to people based on, or less likely to make judgments about people based on who they identify. This slide shows just the amount of data that you give away when you sign an agreement to use a software program. In this case, it's iCloud. Apple is pretty responsible with its data, but look how much it gathers. Every one of those lines is a fact about the person who accepted that, who typed, "I agree." This is the previous scandal. I'm sure most people in the room recognize Mark Ruddy, and this was the scandal that I won't go into, but 26,000 families were denied benefits after receiving benefits because they were suspected of cheating on their government support, their child support, based on an algorithm that misidentified most of them based on criteria gathered from data. The issue here is not that it happened, but that it took 7 years to come to light. And even now, many of the families have not had restitution. Accountability matters, and holding organizations accountable matters. And exactly how that happens is still a work in progress. Organizations that are loosely coupled, where there's diversity of opinion, tend to operate better with high-risk systems, whether they are nuclear power plants like here, 3 Mile Island, or whether they are algorithmic systems. And finally, our final principle is probably very relevant to this group, and I'll close with this. We call it embrace creative friction. Everybody in the world of computers wants to avoid friction. We want things to happen as rapidly and smoothly and easily and as attuned to our brains as possible, because it makes people feel good, it's efficient, and it makes us move on to the next thing. This is one of the most popular books about user interface design. Don't Make Me Think. It turns out that if we want good outcomes, we have to think, and we have to feel, and we have to communicate about the intent and outcomes of what we do. One of the researchers who studied this is David Stark. Diverse teams in organizations here, this is a financial institution on Wall Street, they take longer to deliberate, but their outcomes are better. They get better results. In the end, all of these principles and whatever other principles emerge, they're going to feel uncomfortable to many of us, as many of the diversity practices felt uncomfortable to many people and still may feel uncomfortable to some. AI, as I said, is a forcing function. It's going to require us to find ways to talk about these uncomfortable things in ways that they get heard by decision makers, by governments, by engineers, by business leaders, by social justice activists, and by all of us.